Hey there, kids. Welcome back. This is Module 3. Lessons 9 and 10, really the same objective. We're going to cover Lesson 9 in today's video. The objective for both of these is to add fractions by making like units, and we are dropping the area model. So, I mean, really, hooray, who's not a little happy about that? And we're going to get sums. Of course, that's the answer to an addition problem. And as we get into Lesson 10, the sums will get larger. But for Lesson 9, we'll still have small sums, maybe a little bit over 1, but less than 2. And then they just keep getting bigger and bigger. So really important notes today. Let's get these down pretty please. Very important term, scale factor. A factor is simply a number you multiply with, and the scale is going to change our fractions so that we can get the equivalent number on the bottom. So each fraction will have a different scale. So the different scale factor is, for one, it might be 3/3, but for the other, it might be 2/2. And it's not going to be the same because we're starting out with different numbers and we're trying to make them the same. So the strategy here is going to be to skip count. We want the lowest common denominator, or the least common multiple. LCM is another thing you might see mentioned on a test or a paper. But basically, that just means start skip counting by the denominators. So our original problem of 1/2 plus 2/3 has a 2 and a 3 on the bottom. So line up your 2, 3, and skip count. Now the scale factor, of course, I'm writing them 2 times, but this is basically times 1. You can start here with times 1 as well. And then times 2, so skip count, times 3. And as soon as they have a number in common, that is the one you want to use. I've done this on a couple of previous videos briefly, but this is the lesson where we really jump in. So just keep in mind that a fraction is a ratio. It's got a relationship between the top and the bottom number. So it's super important. If you change one of them, you have to change both at the same rate. So if you change either the top or the bottom, you've got to change the other one. So if I'm changing 1/2 and I'm multiplying by 3 to get the 6, I have to multiply by 3 as well to get this, because 3/6 are equivalent to 1/2. If you forget to multiply by that and you leave it at 1, then 1/2 is not equal to 1/6. It's not, and you would have a big problem. So some sample work that we have down here, actually finishing this out, 1/2 plus 2/3. Here is your equivalent for the 1/2, 3/6, and here is your equivalent for the 2/3, 4/6, and you're going to add them up. Remember, only add the top. Do not add the bottom. The bottom is essentially just a label telling you what the fractions are made of. These are made of sixths. And then we will get a lot of improper fractions in today's lesson. For example, 7/6 has more on the top. When this happens, you have to divide the top by the bottom. It's really easy though, because you can just fit 6 into 7 one whole time. Look for how many times you can fit this into here. Most of these today will just be one time. And then the difference between them, or subtract 7 minus 6, that's going to be your numerator over that common denominator that'll carry all the way through. So here's another one, 5/9 plus 5/6. If I have ninths and sixths, that's a little bit bigger. I sure don't want to multiply and use 54. So if you skip count, you can see that 18 is actually the lowest common denominator between 9 and 6. And it's so much easier just to multiply by 2/2 to get 10/18, and then by 3/3 to get 15/18, instead of having 54ths and all the numerators that go with it. It would be so huge. It's just bleh, yuck. Who wants to do that? Not me. So then we have a simple addition problem. 10 plus 15 is 25. And then you still have to flip this because this is an improper fraction. So you want to divide 25 by 18, which 18 goes in one time, and then find the difference, subtract 25 minus 18 to get that 7 out of 18. One more problem on the back. And this is actually a fun thing. Okay, so you're going to have 3 add-ins potentially on a couple of problems. And so they all have different denominators. So instead of multiplying everything together, again, just line them up. The strategy is to skip count. And up here, we've got our scale factor. This is where you're going to be identifying how many times you have to multiply the number. But we won't always and forever be writing everything out with the scale factors multiplied. So you're going to start thinking about, here's my multiplication with the scale factor in order to get that common denominator. So how do you get from 3 to 12? Well, the scale factor is 4/4. What you do to the bottom, 3 times 4 is 12. You do to the top, 2 times 4. You must multiply the top as well. That's where I got the 8. 2 times 4 is 8. How about this one? 4 times 3 is 12. So 1 times 3 is 3. 2 times 6 is 12. So 1 times 6 is 6. And that's how you get these top numbers, the numerators, that you would then add over 12, flip it into a mixed number, and you have 1 5/12. Again, 12 goes into 17 one whole time with 5 left over out of 12. Now, what is this London's way? This is still in my notebook. Basically, I had told the kids a few years ago, I said, this is how I used to do it when I was growing up. It's like old school. And London says, I love this way. I want to do it all the time. And I said, you go right ahead. So this is just taking that same problem. Look, 2/3 plus 1/4 plus 1/2. And instead of having the scale factors like in your head or all smashed, there's no room in here. We used to have them out here on the side so that you could see what was happening all the way across. They don't do it this way anymore because algebraically and in the higher grades, everything is always written out this way, so they kind of discourage us from doing this now. But anyway, if you just want to solve these problems and this is the only way you can figure it out, I would never stop you from doing it this way. So those are your notes today, and it's kind of a lot, but let's get into that problem set. This is lesson 9 problem set, and we do not have to make area models anymore, so yay. And I know you can do this. You are going to love it. So let's take a look. If I have 3/4 plus 1/7, okay, and I am thinking about the multiples, like you can still think about 4 and 7 and skip counting. So if I was going to, and I like to start with the big number, if I was going to skip count 7, 14, 21, 28, I'm thinking, gosh, that's not a multiple of 4. That's not a multiple. So sometimes you're just going to look at them and say, I have to just multiply anyway. So this is the scale factor. So we're going to take our 3/4 and we're going to multiply both parts by 7. Okay, and then to that we're going to add, here's our 1/7, but the scale factor is 4/4. Okay, so we're setting it up so we can understand how the multiplication changes this into our equivalent fraction. So we knew we needed 28ths, and we were going to get them, but here's where the scale factor is affecting this numerator. 7 times 3 is 21. Now note that we've talked about this before. If this is my scale factor here, I will multiply it by this number as well. Okay, this cross multiplication is what it's going to be called. 7 times 4 is 28, and so this 4 times 1 here is 4. When you have 21 plus 4, you get 25, and so we end with a simple fraction that does not need any changing. So for B, and if you want to, of course, give yourself some space, you can section off a little bit of space. Now for this one, it's a great example of why skip counting can be really helpful. If I was to do our area model strategy, I would end up multiplying 8 times 4 to get 32. Now, could I solve it with 32 as a denominator? Yes, I could, but why would I want to? Remember, I'm looking for a way to get the same number on the bottom, and I want the lowest. Well, I know that 4 times 2 is 8. So if 2 is my scale factor, take 2 halves and multiply it by your 1/4. This is the only thing that needs to change here. I can leave 9/8 alone. 8 is the denominator that I want. 4 times 2 is 8. Therefore, 2 times 1 is 2. This is still equivalent to 1/4, and I can add that to 9/8. If I add that, I get 11/8, and 8 can fit into 11 one whole time with 3 left over. Okay, so it's just better if you can use that lowest common denominator the very first time and not have to use 30 seconds and then try to simplify. Kids are still super not sure about that simplifying step. Oh gosh, now here we have 8 and 7, and those are very close together. When they're very close together, you're going to have a hard time finding a lowest common denominator with skip counting. So it just so happens that they do not have a common multiple, and we do have to multiply by the opposite number. So let's set it up. If I have 3/8, I have to multiply by 7/7 in order to get my 56th common denominator. To that, we're going to take our 3/7 and we're going to multiply it by the opposite scale factor, which is our 8/8. Whatever you do on the bottom, you have to do on the top. Okay, multiply. Sorry, I left these hanging. 3 times 7 is 21. We have our 56 on the bottom, and 3 times 8 is 24. Add only the numerators. Do not add the denominators. Remember, this is like a label. And that's all there is. I can't simplify this. You should always think about, is there a number that I could divide it evenly into both of these to simplify? But I can't. Not on this one. Okay, and another one. This one, 9 and 7. If you wanted to line them up and skip count and see, you could do that. That's the strategy for today. But also, I know that they don't have anything in common. So I'm going to take my 4/9 and I'm going to multiply by 7/7. And to that, I'm going to add my 4/7. And I'm going to multiply by 9/9. Okay, so we're putting that scale factor to work here. We know we're going to end up with 60/3. Okay, because of the 7 times the 9. And then you have to change the numerators at the same rate that you changed the denominators. So here we have 28, and here we have 36. Getting some pretty big addition problems now, so be very careful. If you have to set it up over here so you can do your regrouping, please do. 8 and 6 is 14. So if I do this, I have this 1. I have to carry it over to the tens place. 3, 4, 5, 6. So I have 64 60/3. Trust that you've done the math or check it over here. 64 divided by 63. So remember, it's just going into it one time and then do the subtraction to find out what's the difference. And then that's your final answer. Remember to make them all mixed numbers and don't leave it improper. Oh, and click subscribe and come back again for more helpful math videos. I really hope they're helping you. Okay, 5 and 3. Well, that's pretty low, and we don't have anything lower than 15 that is a common denominator. So we're going to use each of these as the scale factor. So I have 1/5 times 3/3. That's my scale factor. Plus 2/3, the next one, times 5/5. I'm just using these numbers as the opposite scale factor. Now multiply across both the top and the bottom. 3/15 plus 10/15, ending with 13/15. And that's really easy, and there's nothing to simplify. So that was a real nice one. Thanks for the break, math people. Oh, and here's a really good one. Here we have 4 and 6, which we've had so many times in the past. And instead of having 24 pieces, I really don't want to use 24 as my common denominator. So if you think about counting by the largest one first, 6 times 2 is 12. And, you know, 12 is a multiple of 4. So 4 times 2 is 8. But 4 times 3 is 12. So use the multiple as soon as it comes up. So if I take my 3/4 and I have to multiply by something to get 12, here's the scale factor right up here. So in order to get from 4 to 12, I have to use 3 as my scale factor. So set that up. And here's 5/6, and I need to multiply to get the 12. How do I do that? It's with 2 halves. This is my scale factor up here. Remember, the scale factors will be different for each fraction. And so then I can multiply and get 12ths for both of them. 3 times 3 is 9. 5 times 2 is 10. Add them up. Get 19 twelfths. And straighten this one out. It's too big on the top. 19 is bigger than 12, so 12 fits into 19 one whole time with 7 as the difference, and that's your answer. Okay, let's do page 2. All right. So 5 2/3 plus 1 11th. So really odd number. Look, if it's an 11, not going to have a whole lot in common with anything else except 22, 33, and so on. So our scale factor is going to have to be the other number. So let's set that up. 2/3 times 11 11ths plus 1 11th times 3/3. And then we're going to end up with 33 on the bottom of each. Okay, which is what we wanted. And then 2 times 11 is 22, and 1 times 3 is 3. Add these up. And there's nothing else we can do to simplify this, so that one's done. Hooray! And the last regular problem without words, we have 3/4 plus, look, a mixed number. That's cool. What I'm really interested in is simply the denominators, and I'm going to continue trying to get that lowest common denominator. Having a 1 off to the side, or like sitting here as a mixed number, we're going to kind of put it on the side of our problem and forget about it, but keep bringing it down. So I'm just going to shuffle it right over here so we don't forget about it, and then we'll make our equivalent fractions. Now also, between 4 and 10, what is the least common multiple? I don't want to use 40, but fortunately, 10 times 2 is 20. And 4, 8, 12, 16, 20. We do have a 20. Okay, so 20 comes up times 3 times 4, look at that, times 5. So our scale factor for these, for 4 is going to be times 5, so 5/5. Plus, we're going to take only the 1/10 because we put the whole number right here, and we're going to multiply by that scale factor of 2 halves. Bring the 1 down, and to that we're going to add, here's our 20ths, 15 20ths, and here's our 20ths, or here are the 20ths, and we have 2. Add these together, and I end up with 1 and 17 20ths, all in one step. So you just can't forget about that 1, so float it right off here, and then just bring it down, bring it down, bring it down, and then continue everything else like we have been. Okay, so just a couple more problems. Let's see if we can do it without the lights turning off and the Wi-Fi kicking me out. Let's see if it works. Whitney says that to add fractions with different denominators, you always have to multiply the denominators to find the common unit. For example, 1/4 plus 1/6. Look, she multiplied these two and got 24. And I was just saying, what a hassle is that? So show Whitney how she could have chosen a denominator smaller than 24 and solve the problem. So the problem is 1/4 plus 1/6. So what I just said was, hey, let's skip count. So line up your 4 and your 6 and look for a lower common multiple. So 6 times 2 is 12. Remember, that's your scale factor. Times 2 is 8. Times 3 is 12. So since I have a 12 that is a lower number in common, I want to take my 4ths and I want to multiply by my scale factor. And then to that, I'm going to add my 1/6. Then I'm going to multiply by the scale factor, 2 halves. So multiply and get 3/12 plus 2/12, and you end up with 5/12. So we solved it, and we showed Whitney this strategy of skip counting. Hooray. So good luck, Whitney. And finally, we have a couple of word problems. Let's jump right in. Jackie brought 3/4 of a gallon of iced tea to the party. Bill brought 7/8 of a gallon of iced tea to the same party. They did not communicate beforehand, clearly, because they should have had a variety of drinks. How much iced tea did Jackie and Bill bring to the party? We have 3/4 of a gallon and, okay, so looking at the wording, and 7/8 of a gallon. It's all the same thing. We're combining different amounts. Look at this denominator, okay? I do not have to multiply. It's just like what Whitney said. You have to multiply. And I'm saying, no, you don't. In fact, I don't have to change 7/8 at all. I'm just going to bring it right down and leave it the same. I do want to change 3/4 because in order to get eighths, I can use a scale factor of 2/2. I know that 4 times 2 is 8, so I want to only use the lowest number I can. So 3 times 2 is 6, and 4 times 2 is 8. So here we have simply only one number that needs to be changed, this first fraction. So add them up, and then simplify, because we don't want to leave the improper fraction. So 8 fits into 13 one time, with 5 left over. And go back and read what you're finding. How much iced tea? Gallons together of iced tea together. Okay. And let's see if we can get this last one on the same video this year. Madame Curie made some radium in her lab. She's so smart. She used 2/5 kilogram of the radium in an experiment. She used this in the experiment and had 1 1/4 kilograms left. Now, I love these parts. How much radium did she have at first? Part to whole sounds like to me. She used some 2/5, and then she had 1 1/4 kilograms left. Used it, had some left. How much was at the beginning? So we know that tape diagrams can help us with part to whole. Put these two together to get the whole. So let's find out how much she had at first by adding. And remember, if you have a whole number, you can just take it and set it aside and then focus on your fractions at this point. Now I need to have a common denominator because 5 and 4 are not the same. And I want to get 20ths. So because I know that 4 and 5 can skip count 5, 10, 15, 20. And then 4, 8, 12, 16, 20. And so the scale factor for this one is going to be times 5. And the scale factor for this one is going to be times 4. Okay? So let's set these up. 2/5 times 4/4 and 1/4 times 5/5. And then multiply all the parts, tops and bottoms, across. 1 plus 8/20 plus 5/20. And then I'm running out of room, so I'm going to, well, I'll squeeze it down here. 8 plus 5. And we have our 1 13/20, but what does that represent? That represents kilograms of radium at first. Okay, but wait, there's more. So here we have a little piece of the answer, but let's do the extension. If she performed the experiment twice, how much radium would she have left? So that's taking, now remember, this is the experiment here, right here. So if she does it again, okay, so for the second time, that's going to impact how much how many kilograms she would have left. It wouldn't impact the total. So how much would she have left then? So you can take your 2/5 And you can do the doubled amount here. Okay, so that's 2/5 plus 2/5. And if we had that 1 and 13/20, and you can take away the 4/5. Oops. Run that together, take away the 4/5, then we can get our common denominator, 1 and 13/20. And we need to take away our 20th, so 4/5 times 4/4. And then we have our 16/20. And eventually we're going to, this is going to be just done in your head, okay? And so notice that I have 1 and 13/20 minus 16/20. Now this is bigger than this, so don't panic. Do not panic. So take the 1 and turn it into 20/20. Don't forget about this guy here, but take the 16/20 away from that one and end up with 4/20, and then put back your 13/20, and then you have 17/20 kilograms left if she does the experiment twice. So this is the extension over here. Okay, so I sure hope this is helpful, and look, it's all in one video. Feeling like a winner. All right, we'll catch you guys on the next one. Have a great day. Bye for now.